3.7 Factoring Polynomials. When we are factoring polynomials, the first thing we can look at is determining whether a linear binomial is a factor. So remember, a linear binomial is the power is 1 and a binomial is 2 terms. So if we look at example A, we have x minus 3 and p of x is equal to x squared plus 2x minus 3. So we're going to use synthetic substitution to determine if our remainder is 0, then that linear binomial is a factor. So we solve for x in the x minus 3, set it equal to 0, move that 3 over. We're going to have that x is equal to 3. So 3 is going to go inside our box. Our coefficients are 1, 2, and negative 3. So put those down. We're going to drop the first term, multiply it by the 3, we get 3. We're going to add the 2 and the 3 to get 5. Multiply it by the 3, we get 15. From there, we add it to the negative 3, and we're left with 12. Because this remainder is not 0, then x minus 3 is not a factor. That remainder would have to be 0 in order for that binomial to be a factor. For b, we have x plus 4, and p of x is equal to 2x to the 4th power plus 8x cubed plus 2x plus 8. So you see here that we're missing that x squared, so we'll put in that plus 0x squared in between the 8x cubed and the 2x. We're going to use the x plus 4 to solve for x. Move the 4 over by subtracting it. We get that x is equal to negative 4. So the negative 4 goes in our box. We're going to have a 2, an 8, 0, 2, and 8. That first 2 we're going to drop down. Multiply the 2 times negative 4, we have negative 8. Combine that with the 8, we get 0. 0 times negative 4 is 0, and 0 plus 0 is 0. 0 times negative 4 again, 0. So we have 2 plus 0, which is 2. 2 times negative 4 is negative 8. And negative 8 plus 8 is 0. Because our remainder is 0 for this one, x minus 4 is a factor. And if we look at example C, we have x plus 2, and p of x is equal to 4x squared minus 2x plus 5. So again, we're going to take that x plus 2, set it equal to 0, solve for x by subtracting the 2 on both sides. We get that x is equal to negative 2. So the negative 2 goes in our box. Then we're going to have a 4, negative 2, and 5. The 4 comes down. 4 times negative 2 is negative 8. Combine those, we get negative 10. Negative 10 times negative 2 is positive 20. Add that with the 5, we're left with 25. Because that remainder is 25, that x plus 2 is not a factor. For D, we have 3x minus 6, and p of x is equal to 3x to the 4th power minus 6x cubed plus 6x squared plus 3x minus 30. All of our exponents are accounted for, so we're going to take the 3x minus 6, set it equal to 0, move the 6 over by adding it. We're left with 3x is equal to positive 6. Then divide each side by the 3 to get that x is equal to 2. So the 2 is going to go in our box. On the outside, we're going to have a 3, negative 6, positive 6, 3, and a negative 30. So we're going to bring down the first 3, multiply it with the 2, we get 6, add it with the negative 6, we're left with 0. 0 times 2 is 0, add it with the 6, we're at 0. 0 times 2 again is 0, add it with the 3, we have 3. 3 times 2 is 6, add it with the negative 30, we have negative 24. So because that remainder is not 0, 3x minus 6 is not a factor. When we start factoring polynomials, we first have to look to see if we have a greatest common factor with all of our terms. And we factor out that greatest common factor, which means we divide each of those terms by a specific factor. So if we look at example 2a, we have 2x to the fourth power minus 4x cubed plus 8x squared. Well, if you look at all of those x's, they all include an x squared, so we can divide out an x squared from each of these. And they're all even numbers, so they're all divisible by 2 as well. When we factor out this 2x, we're dividing each term by the 2x squared. The 2x squared is going to have to come out front because we're pulling that away from all of those terms. The 2x to the fourth power divided by 2x squared. The x squared is going to cancel. We're going to subtract 2 from the exponent of 4 in the numerator, and those 2's become 1's. So we're just going to be left with x squared. Keep the negative for your next term. The 4 divided by 2 becomes 2. The x cubed divided by x squared, we're going to subtract those 2, and we're going to be left with 2x. For our next term, we have a positive. Then our 2 goes into 8 4 times. The x squared are both the same, so they cancel out as well. So our solution here is 2x squared times x squared minus 2x plus 2. Plus 4. For b, we have 10ab cubed minus 15a squared b squared. So we see that these are both divisible by 5. They both have an a, and they both have a b squared. So we're going to factor out that 5, ab squared. The 10 divided by 5 is 2. A divided by a cancels, and b cubed divided by b squared is just b. Keep the negative. 15 divided by 5 is 3. The a squared divided by a is a, and b squared divided by b squared cancels. So we have 5ab squared times 2b minus 3a. For c, we have 8y cubed z minus 12x squared y cubed plus 4xyz. So if we look at all of these terms, they're all divisible by 4. So we're going to pull the 4 out. Do they all have a y? Yes. What's the biggest exponent on the y? The smallest exponent on y is a 1. So we'll pull just one y out. Do they all have a z? No. Do they all have an x? No. So the only thing you can divide out from each of these terms is a 4y. So we're going to take the 4y, put it on the outside, and then divide each term by the 4y. So 8 divided by 4 is 2. Y cubed divided by y is y squared, and that z is going to stay. For our second term, it's going to be negative. 12 divided by 4 is 3. X squared is going to stay. Y cubed divided by y is y squared. The last term, we have a positive 4 divided by 4, which is just a 1. Do we need to write the 1 in front of the variable? No. So we keep the x, the y's are going to cancel, and we keep the z. So we have 4y times 2y squared z minus 3x squared y squared plus xz. For d, we have 50x cubed y squared plus 25x squared y. We know that both of these are divisible by 25, so we'll pull that out. They both have an x. The smallest exponent is 2, so we'll pull an x squared out. They both have a y. The smallest exponent is 1, so we'll also pull a y out. So the 25x squared y goes on the outside. Divide the 50 by 25, we get 2. X cubed divided by x squared is x, and y squared divided by y is y. For the 25 divided by 25, that's a 1. Do we need to write the 1 in front of the variable? No. However, the x squared divided by x squared cancels, so does the y divided by y. So you have to put that 1 down. So we have 25x squared y times 2xy plus 1. If we look at our next set of examples, we are using the formula ax squared plus bx plus c to find the factors of c that add up to b. So we're factoring each of these. When we take this polynomial and we factor it, we have to look at that c and keep the sign in front of it with it. So if we look at example A, we have x squared minus x minus 6. That negative 6 is what we have to find the factors of that add up to be a negative 1, because our b is a negative 1. So the factors of negative 6 are negative 1 and 6, negative 2 and 3, as well as 1 and negative 6, and also 2 and negative 3. So which of these are going to give us the sum of negative 1? Well, when we add the 2 and the negative 3, that gives us a negative 1. So we're going to use both the 2 and the negative 3 to separate this into x plus 2 times x minus 3. Remember, with these, you can always check your answer by foiling this out, multiplying the 2, and you should get the same exact polynomial that you're starting with. So for example, if we did x times x, that's x squared. X times negative 3 is negative 3x. 2 times x is positive 2x. The 2 times negative 3 is negative 6. So now combine your like terms. We have x squared minus x minus 6. And that's the exact same thing that we started with, so we know that our answer is correct. For B, we have x squared minus 11x plus 18. So we're looking for the factors of 18 that add up to be a negative 11. Now, think about it. When you do a multiplication and you have a positive, both of your numbers that you're multiplying either have to be positive or they have to be negative. If we're ending with a negative 11 when we find the sum of those two factors, that means that both of our numbers are going to have to be a negative in order to get to that 18 when we multiply them. So the factors of 18 that are negative are negative 1 and negative 18, negative 2 and negative 9, negative 3, negative 6. We want to find the ones that add up to be negative 11, which is the negative 2 and the negative 9. So we're going to have x minus 2 times x minus 9. Again, if you want to check your answer, FOIL this out, x times negative 9. Negative 2 times x, negative 2 times negative 9. When you combine like terms, you should end with the x squared minus 11x plus 18. For C, we have x squared plus 15x plus 56. So look at your C term. We have 56. We got to find the factors of 56. Your B term is a positive 15. So when we find the factors of this 56, we're dealing with a positive and a positive, because a positive times a positive is a positive, and a positive plus a positive is positive. So 56, we have 1 and 56, 2 and 28. Does 3 go into 56 evenly? Add up the numbers. 5 plus 6 is 11. 11 is not a multiple of 3, so no. Does 4 go into 56 evenly? Yes. 4 goes into 5 once with 1 left over, and 4 goes into 16 4 times. So 4 times 14. Next, we go to 5. Does 5 go into 56 evenly? No. Does 6 go into 56 evenly? No. Does 7 go into 56 evenly? Yes. 7 times 8 is 56. If we keep going, we're going to go to the 8, and that's going to be 8 times 7. Then the next one will be 14 times 4, 28 times 2, and 56 times 1. So we can stop there. Think of all of these. When we add these up, do any of them give us a sum of 15? Yes. The 7 and the 8 give us 15. So the 7 and the 8 are what we are going to use when we do our parentheses. So x plus 7 times x plus 8. Again, multiply this out. If you get the same answer, or if you get the multiplication of it to be the same trinomial that you started with, you know your two parentheses are correct. For D, we have x squared minus 4x plus 12. Our C term is that 12. We have a negative 4. So in order for us to have a negative for our answer, both numbers, when multiplied, have to be negative when we find the sum of them. So we're going to have a negative 1 and a negative 12, a negative 2 and a negative 6, a negative 3 and a negative 4. Do any of these add up to be a negative 4? No. This is a negative 7, this is a negative 8, this is a negative 13. Because none of these add up to be a negative 4, this one is prime. sometimes we'll be dealing with perfect square trinomials. When we have perfect square trinomials, we are dealing with two different formulas. We have a squared plus 2a plus b squared, or a squared minus 2ab plus b squared. When we look at these, what we're going to do is we're going to look at that c term. If we take that c term, is it a perfect square? Yes. So if we look at example A, we have x squared minus 8x plus 4. The 4 is our c. Can we take the square root of that 4? Yes. It's equal to 2. So that 2 would be our b. From there, we would take the a term, which is the square root of the first term, our x squared, which is x. A is equal to x. From there, if we take the sign in the middle is negative, it's negative 2 times a times b should be the negative 8x. So if we plug these values in, we have negative 2 times x times b, which is 2. So then this is going to give us a negative 4x. Does this give you the negative 8x? No. So is this a perfect square trinomial? No, it's not. It's also prime because no factor of 4 gives you a negative 8. You could factor these the same way that you did with the ones before this, where you find the factors of c that add up to be b. That's perfectly fine. If we look at b, though, we have x squared plus 6x plus 9. Take the square root of your a is x. Take the square root of your c is 3. You have a positive here in the middle for your b, so you're using a positive 2 times a times b should give you the 6x. So plug these values in. 2 times a times b is 2 times x times 3, which is 6x, and that's equal to 6x. So yes, this is a perfect square trinomial, or yes, perfect square trinomial. So you're going to have parentheses x plus, what was your c? Or your c, 3 squared. Okay, so whatever you take the square root of, that's what's going inside your parentheses. And then the sign that's in the middle with your b gives you the sign that's in between those two terms. If we look at c, we have 4x squared plus 36x plus 81. 4x squared is a perfect square. 81 is a perfect square. Take the square root of the 4x squared, we get 2x. So our a is 2x. Our b, that would be in our binomial squared, is going to be the square root of that 81, which is 9. So check. We have a positive in front of the 36x, so a positive 2ab should equal 36x. So plug these in. We have 2 times 2x times b, which is 9, is equal to 36x. So 2 times 2 is 4. 4x times 9 is 36x, which equals 36x. So our a was the 2x, our b was the 9. So in our parentheses, we're going to have 2x, the sign on b is positive, plus 9 squared. For d, we have 9x squared minus 24x plus 16. We can take the square root of that 9x squared. We can take the square root of that 16. The square root of that 9x squared is going to give us an a of 3x. And that square root of 16 is going to give us a b of 4. We have a negative on our b term, so it's going to be negative 2ab is equal to negative 24x. So plug in those values. Negative 2 times 3x times 4 should give us a negative 24x when we simplify it. Negative 2 times 3x is negative 6x. Negative 6x times 4 is negative 24x. That is a true statement. So our answer for this one would be parentheses 3x. B has a negative on it, so we're going to have a negative in between the two terms. B is 4. So 3x minus 4 squared. For our next set of examples, we're doing the difference of two squares. So what we have here is a binomial where our a term is squared and our b term is something squared. So if we look at example 5a, we're factoring the binomial. We have a squared minus 9. We can take the square root of a squared. We can take the square root of 9. We have a negative in between these two. So once we take the a, which is the square root of a squared, which is a, and our b is the square root of 9, which is 3. We're going to use the formula a minus b squared. I'm sorry, a minus b and a plus b. I'm sorry. So a minus b and a plus b. Sorry about that. Okay, so plug these values in. Our a is a. Our b is 3. So we're going to have a minus 3 and a plus 3. Difference of signs. Two perfect squares. For b, we have x squared minus 121. We can take the square root of that x squared. We can take the square root of that 121. We have a negative in between. So we use the formula a minus b times a plus b. Our a is the square root of that x squared, which is x, and our b is the square root of that 121, which is 11. So plug these values in. We're going to have x minus 11 times x plus 11. For c, we have y squared minus 225. We can take the square root of that y squared. We can take the square root of that 225. We have a negative in between, so we're using the formula a minus b times a plus b. Find a and b. A is the square root of y squared. B is the square root of 225. So a is y, b is 15. Plug it into your formula. We're going to have y minus 15 times y plus 15. For d, we have x squared minus 64. So can you take the square root of the x squared? Can you take the square root of the 64? Yes. Use the formula. You also have a negative. Use the formula a minus b times a plus b. So from here, your a is the square root of that x squared. Your b is the square root of that 64. So a is x, b is 8. Plug them into your formula. We're going to have x minus 8 times x plus 8. Again, just like with all the rest of the ones that we've done so far, you can FOIL these out, multiply them, and you should be getting the same binomial or trinomial that you're starting with. Sometimes we're going to be factoring by grouping as well. When we do this, we start with 4 terms. Remember, if you can divide every single term by a common factor, you can do that first. If we look at example 6a, we're factoring each polynomial by factoring, yes, by grouping. So we have for a, x cubed plus 3x squared minus 4x minus 12. So we're going to set parentheses on the first 2 terms and the last 2 terms. And we're going to divide out a common factor from the 2 terms that we just put parentheses around. So the x to the 3rd power and the 3x squared have a common factor of x squared. So we're going to divide each of those by x squared. The negative 4x and the negative 12 have a common factor of negative 4. So we're going to factor out a negative 4 from both of those terms as well. So this is going to leave us with x squared times x plus 3. Where the 4 is going to factor out to be negative 4 times x plus 3. Because both of those parentheses are the same, we are going to write one of those down and then form another set of parentheses with the x squared and the negative 4. Now, think about this. This is not factored completely. That x squared minus 4 is what? You can take the square root of the x squared. You can take the square root of that 4. There's a negative in between them, so it's a difference of squares. So this is going to be x plus 3. That x squared minus 4 is the same thing as x minus 2 times x plus 2. So this is your final answer. When it tells you to factor, it has to be factored completely. That x plus 3 times x squared minus 4 is not factored completely because that x squared minus 4 is the difference of squares. So you can go ahead and factor that out further, just like we did with the examples before this. For B, we have 2x cubed plus x squared plus 8x plus 4. So we'll put your first set of parentheses around the 2x cubed plus x squared, and your second set of parentheses around the 8x plus 4. So the 2x cubed plus x squared shares a common factor of x squared. The 8x and the 4 share a common factor of 4. So with the 8x plus 4, we're going to divide each of those by 4, and the 2x cubed plus x squared, we're going to divide both of those by x squared. So this is going to leave us with x squared times 2x plus 1. And the 4 is positive that we're bringing out, so plus 4 times 2x plus 1. From here, our two parentheses are the same. So we're going to have 2x plus 1 times x squared plus 4. Now, yes, you can take the square root of that x squared. Yes, you can take the square root of that 4. But because that positive is there, you cannot factor this one any further. So our answer is just the 2x plus 1 times the x squared plus 4. If we look at example C, we have x cubed minus 2x squared minus 9x plus 18. So again, put parentheses around the first two terms and then around the second two terms. The x cubed minus 2x squared shares a common factor of x squared, so we'll pull that out. The negative 9x and the positive 18 share a common factor of negative 9, so we'll pull that as well. So we're going to have x squared times x minus 2, as well as negative 9 times x minus 2. So because those two sets of parentheses are the same, we're going to rewrite them towards x minus 2, and then we have x squared minus 9. Now look at your two terms. You can take the square root of x squared, you can take the square root of 9. You have a negative in between the two. So your a is the square root of x squared, which is x. Your b is the square root of 9, which is 3. Do the difference of squares. You're going to have x minus 2 times x minus 3 times x plus 3. For D, we have 9x cubed plus 8x squared. We'll put parentheses around that. And then the x plus 2. The 9x cubed plus 18x squared, we can divide both of those by 9x squared. The x plus 2 doesn't share a common factor of anything other than 1, so we'll pull out a positive 1 there. So we're going to have 9x squared times what's left over, x plus 2, and then a positive 1 times x plus 2. So if we write these in as two sets of parentheses, we're going to have an x plus 2 times 9x squared plus 1. Again, you can take the square root of that 9x squared, you can take the square root of 1, but because there's a positive between the two of those, you cannot factor that any further. So the x plus 2 times 9x squared plus 1 is your final answer. Sometimes you're going to have these polynomials where your a term is not 1 and you can't factor out a common factor with all of them. So if we look at example 7a, we have 2x squared plus 11x plus 12. We can't factor anything out from any of these because none of them share a common factor other than 1. So what you do from here, you're going to multiply your a and your c. So we have 2 times 12. From here, we get 24. We are going to find the factors of 24 that add up to be our b term. Okay, so same concept, but now we're multiplying the a and the b. So from here, we have 1 and 24, 2 and 12, 3 and 8, 4 and 6. The 3 and the 8 can add to give us 11. So when we rewrite this, we're going to use the first term, which is that a, so 2x squared, the two factors of that 24 that we found that got us to the positive 11x, adding an x on them. So we're going to have a positive 3x and a positive 8x. And then we're going to rewrite our c term. So now we have 2x squared plus 3x plus 8x plus 12. We are going to factor by grouping. We have 4 terms, factor by grouping. The 2x squared plus 3x can only factor out an x. The 8x and the 12, we can only factor out a 4. So this is going to be x times 2x plus 3 plus 4 times 2x plus 3. So our two parentheses are the same. We're going to rewrite those as 2x plus 3. And then we're going to make another set of parentheses with the x and the positive 4. So x plus 4. We cannot work any further from this. So 2x plus 3 times x plus 4 is our solution for this one. So again, we're multiplying our a and our c, getting the two factors that add up to be our b, rewriting as a polynomial with 4 terms, and then factoring by grouping. For b, we have 5x squared minus 4x plus 18. So our a is 5, our c is 8. We're going to multiply the 5 and the 8 to get 40. We want to find the factors that equal negative 8 or negative 14. So remember, a positive times a positive is a positive. A negative times a negative is a positive. A negative plus a negative is a negative. So we want 2 negatives here. So we're going to have a negative 1 and a negative 40, a negative 2 and a negative 20, a negative 4 and a negative 10, a negative 5 and a negative 8. So the negative 4 plus the negative 10 is going to give us that negative 14 that we're looking for. So we're going to use those two factors when we rewrite this polynomial. So I'm going to rearrange these so that way my like terms are, or my terms that are together, that are going to be in the same parentheses, we can actually divide out a of something from both of them. So we're going to start with the 5x squared. I have a negative 10x and a negative 4x, as well as that 8. So I'm going to factor by grouping now. The 5x squared minus 10x shares a 5x, and that negative 4x and that 8 share a negative 4. Look at the 5x squared, look at the negative 4. You always want those first two terms in the set of parentheses to have the same sign. If they don't, you have to factor out a negative with whatever you're factoring out. So this is going to be 5x times x minus 2, and then negative 4 times x minus 2. Our two sets of parentheses are the same, so we're going to have x minus 2. Then we're going to make a set of parentheses with the 5x and the negative 4. So x minus 2 times 5x minus 4 is our factored out 5x squared minus 14x plus 8. For c, we have 6x squared plus 17x plus 5. Can't factor anything out to start with, so multiply the 6 and the 5. We get 30. We want the factors that add up to be a 17. So for 30, we have 1 and 30, 2 and 15, 3 and 10, 5 and 6. The 3 and 10 give us 13, but we're looking for a 17, so that 2 and that 15 give us the 17 that we're looking for. So we're going to do 6x squared plus 2x plus 15x plus 5. Factor by grouping. The 6x squared plus 2x, we can factor out a 2x. The 15x plus 5, we can factor out a positive 5. So 2x times the 3x plus 1, and then the positive 5 times 3x plus 1. We're going to have the same set of parentheses here, so this 3x plus 1 is going to be 1, and then the 2x plus 5 makes itself a parenthesis. So 3x plus 1 times 2x plus 5 is our solution for this one. If we look at our next example, D, we have 9x squared minus 15x plus 4. So we're going to take that 9 and that 4 and multiply those together. When we do, we get 36. We find the factors of 36 that equal a negative 15 when we add them together. Now, remember, the negative times a negative is a positive, but when we add them, we still have a negative. So the 36 is 1 and 36. 2, and 18, 3, 12, 4, 9, 6, and 6. So again, we're looking for a negative 15. So they both have to be negative here. When we go ahead and add these up, if we add the 3 plus the negative 12, we're going to get a negative 15. So those two work. So we're going to use the 9x squared, then the 3x, which is negative, and then the negative 12x plus 4. We are going to factor by grouping. The 9x squared minus 3x, we can divide out a 3x. The negative 12x and the 4, we can divide out a negative 4. The reason why we're dividing out a negative is because that a term in both of the set of parentheses needs to be positive. So if you divide the negative 12 by a negative 4, it's going to make it a positive 3. So the 3x comes out. The 9x squared minus 3x divided by the 3x is going to give us 3x minus 1. And then if we divide out the negative 4 from the negative 12x plus 4, it's going to give us 3x minus 1. So our two sets of parentheses are the same. We're going to rewrite one of them and then make another set of parentheses with a 3x minus 4. So we have 3x minus 1 times 3x minus 4. And this is our solution here because we can't factor either of those parentheses any further. If we look at our next set of examples, we have the sum and difference of two cubes. When we're dealing with the sum and difference of two cubes, we're dealing with these specific formulas. So we're looking at a binomial where if we take the cube root of both our a and our b term, we can realize that we have these two formulas that we can use. And those formulas all depend on the sign that's in between those two perfect cubes. When we are dealing with two perfect cubes with a positive in between them, like we are with example A, we have 5x to the 4th power plus 40x. We are going to make sure that we factor whatever we can first, which we can pull out or divide both of these terms by a 5x. So we'll do that first. We'll have 5x times x cubed plus 8. Now we can take the cube root of that x cubed as well as the cube root of that 8. When we do so, that a is going to be our cube root of x cubed, and that b is going to be the cube root of that 8. The cube root of x cubed is x. The cube root of 8 is 2. So now we work with the formula. There is an addition sign between these two. So we're going to use the formula a plus b times a squared minus ab plus b squared. Okay, so the sign on the first set of parentheses will always be different than the sign on the middle term in the second set of parentheses. The one that has the same sign as the binomial that you're working with to factor is going to be the same sign as what's in the front parentheses. So we have the a, which is the x, the b, which is 2. We're plugging these values in, but remember, you need to keep that 5x out front. We've factored that out so it just doesn't disappear. You have to represent it within. So the a is x. We're going to have x plus b, which is 2, times x squared minus x times b, which is 2, plus 2 squared. So simplify this if you can, which we can. So we're going to have 5x times x plus 2. Nothing's changing there. Then the x raised to the second power is x squared. The negative x times 2 is negative 2x. And that 2 squared is 4. So we'll put that plus sign in between the 2x and the 4. So 5x times x plus 2 times x squared minus 2x plus 4. If we look at example B, we have a negative in between these two perfect cubes. So we'll go ahead and use the formula a minus b times a squared plus ab plus b squared. First, find what a and b are. So a is going to be the cube root of 8y cubed, and b is going to be the cube root of 27. So the cube root of that 8y cubed is 2y. So a is 2y, and b is going to be the cube root of 27, which is 3. So again, we're using the formula. There's a negative there. We're going to start with a negative, a minus b times a squared. Opposite of negative is a plus, ab plus b squared. So fill in here. So the a is 2y, the b is 3. So this is going to become 2y minus 3 times, I'm going to make this a bracket, 2y squared plus a, which is 2y, times b, which is 3, plus 3 squared. And now simplify. So the 2y minus 3 stays. The 2y squared is 2y times 2y, so that's 4y squared. 2y times 3 is 6y, and then the 3 squared is 9. So 2y minus 3 times 4y squared plus 6y plus 9. If we look at example C, we have 8 plus x to the 6th power. We can take the cube root of that 8. We can take the cube root of that x to that 6th power. So do that for both. A is going to be the cube root of 8. B is going to be the cube root of x to the 6th power. So the cube root of 8 is 2. The cube root of that x to the 6th power is x squared. So now use your formula. We have an addition sign between these two perfect cubes. So we're going to use a, same sign, plus b times a squared, different sign, minus ab plus b squared. So plug in now. 2 plus x squared times, make it a bracket, 2 squared minus 2 times x squared plus x squared raised to the 2nd power. So now simplify. The 2 plus x squared is not going to change. Then we're going to have 2 squared, which is 4, minus 2 times x squared, which is negative 2x squared. And that plus x squared raised to the 2nd power. So we multiply those powers. It's going to be a positive x to the 4th power. So 2 times x squared times 4 minus, 2 plus x squared times 4 minus 2x squared plus x to the 4th is our solution here. Oops. For D, we have 2x to the 5th power minus 16x squared. Now look at both of these terms. They both contain an x squared, and they're both divisible by 2. So we're first going to divide out a 2x squared before we do anything else. So 2x squared times, what's left over when you divide out that 2x squared? X cubed minus 8. So again, you can take the cube root of that x cubed, you can take the cube root of that 8. So a is the cube root of x cubed, which is x, and b is the cube root of 8, which is 2. So now use your formula. Remember about that 2x. We're going to have 2x squared times a, our sign is negative, minus b, times a squared plus ab plus b squared. So now fill in. We have 2x squared, that's not going to change, times a, which is x, minus b, which is 2, times a squared, so that's going to be x squared, plus a, which is x, times b, which is 2, plus b squared, which is 2 squared. So now simplify. The 2x squared is going to stay. The x minus 2 doesn't have to change. The x raised to the 2nd power is x squared. The x times 2 is positive 2x. And the 2 squared is 4. So we have 2x squared times x minus 2 times x squared plus 2x plus 4.